are Badgers for Bentonville, and we are designing mountain bike training wheels for UW-Madison's Intro to Engineering 170 class.
Our client is Elise Uphoff and her 15-year-old son Emerson, who has dyspraxia and full-body dystonia that impair his coordination and movement and prevent him from engaging in physical activities such as mountain biking. Our goal is to design an adult-sized training wheels that have 5-minute quick-release removability, are compatible with Emerson's 29-inch wheeled mountain bike, and are capable of riding on varied mountain bike terrains, including trails that can be up to 2 feet wide.
Emerson's current system is a trike, which is very wide, making it difficult to ride on mountain biking trails. So we would like to complete this project in a budget of under $300 by May 4th of this year. Our first step was to brainstorm our design. Our design went through many phases, including in-frame suspension, curled wire providing suspension, and a design without suspension. In the preliminary design presentation, we decided on the suspension in-frame design. However, after much deliberation, our team decided suspension was not feasible with our time, experience, or budget, and we instead focused on making the safest possible training wheel system. We created a design that incorporated a steel frame and aluminum quick releases attached through screws and welding.
In order to fabricate our prototype, we first measured the bike and created CAD models. We cut aluminum using a water jet to create the quick releases. The quick releases were cut to size and holes were drilled to allow screws to pass through. Then, we welded together the steel pipes to create triangular frame components. The frame was compressed using a hydraulic press and attached to the wheel through screws. The final design consists of 3 main components: the frame attachment to the bike, and the frame attachment to the training wheels. The frame is made out of a steel aluminum square rod and was made in a triangular shape to provide added stability. The second part of the frame are the 3 rods that reach out towards the bike at an angle. The frame is attached to the bike frame through 3 quick release connection points. The aluminum quick releases are operated by nuts and bolts that allow the half-circle attachments to be tightened around the bike frame at 3 points. Finally, the frame is connected to the training wheels through a nut and bolt system. The end of the frame has a horizontal hole drilled that allows the axle of the wheel to slide through, and a nut is used to secure the wheel. Our tests included timing the installation and removal of the wheels, a weight test, a terrain test, and an unbiased review of the bike based on multiple categories. We found that the system takes 7 minutes to install and 4.1 minutes to remove. The wheels can function on terrain such as gravel, grass, and upwards and downward slopes. The system can support over 200 pounds of weight. An unbiased review has rated the bike 5 out of 5 for comfort, 4 for stability, 3.2 for ease of turning, and 5 for safety. Although we were not able to include suspension as initially desired, our bike satisfies the other categories. Badgers for Bentonville is proud to have worked with the UW College of Engineering, Makerspace, and Team Lab staff to complete this project.